Okay, so in this video we're going to look at the ideas of paths and circuits in graph theory, and one thing to keep in mind is these terms are not very universal. For whatever reason, the definitions, the terms used in the definitions in graph theory tend to vary from textbook to textbook and instructor to instructor. So sometimes instead of the word path you see walk, or instead of the term circuit you see the word cycle. They mean the same thing, it's just again, for whatever reason, I don't know if mathematicians haven't been able to decide what these things should be called or what the deal is, but there is a wide range of terms and of notation used in graph theory. So I think the idea of a path is pretty intuitive. If you start at vertex A, you just start following some edges and get to where you want to go. So if you want to get from, say, A to F, you have to follow edges, right? So I couldn't go, for instance, I couldn't go from A to D and then D to B because there's no path from D to B. There's no edge connecting D and B. So I have to follow edges, and so I might go A, B, C, F, A, B, C, F. So typically you list the vertices that, right? So you start at A, go to B, go to C, go to F. That's typically how you see a path notated. Again, it can vary. Sometimes these have parentheses around them. Sometimes they have braces around them. But we'll just list the vertices that we follow. So this is an example of a path. Of course, there's other paths that would get you from A to F. You could go from A to E to F. That might be the quickest. From A to E to F. Of course, that's another path. Or you could list any number of paths going from between any two vertices that you wish to travel between. And there is the idea of a simple path. Both of these actually that I listed are simple paths because they do not repeat any edges. So an example of a path that's not simple might be something like this. If you wanted to get from A to F, and I don't know why you would do this, but let's say you went from A to D, back to A, and then you went to B, and to C, and to F. Right? You made a wrong turn and you had to backtrack. Well, you repeated this edge more than once, so that is not a simple path. And that's an idea that will be used, the idea of a simple path. Okay, so then what's this idea of a circuit? Or if you think of it as a cycle, you can probably guess what that might be. That means that you go off on some path and you end up back where you started. So you might do something like go from A, let's say we go from A to B to C, and we cut back to D and then back to A. Okay, so you can see that in a, so this is an example of a circuit. Right, a circuit where you basically go in a circle. Circle isn't the right word because it wasn't a circle, but you end up at the same place that you started. And so we can distinguish between a circuit and a simple circuit. This actually is an example of a simple circuit because, again, there's no repeated edges, right? So if we repeated an edge, then that would not be a simple circuit. So let's see if we can think of one. Let's say we started A, and let's go to E. So let's see, we started A, we go to E, then we're going to go to B, we're going to go to B, then we're going to go to C. We're going to go to C, and then let's go to F, and then let's go back to B, and then we're going to go down to E. Okay, so there we repeated this edge. We repeated this edge between B and E, and then let's say we go to D and then back to A. Okay, so we did complete a circuit, but it was not a simple circuit because we repeated an edge. And again, some textbooks don't even distinguish between paths and simple paths, circuits and simple circuits. But in this case, we will. I think that probably does make life a little bit easier to have a different term when you don't repeat any edges. But ultimately, I think those ideas are, no pun intended, but simple and relatively intuitive. I mean, if you just had to guess what a path or a circuit was, it probably would be pretty close to what you might guess. So hopefully nothing too difficult with these ideas.